today I want to show you one of the most popular digital forensics and incident response tools being used in the community at the moment. This tool is called KAPE, K-A-P-E, and it stands for Crawl, Artifact, Parser, and Extractor. It's a tool that was written by Eric Zimmerman, and when it comes to data breach investigations or really any type of cyber-related incident, time is always of the essence. And so therefore, we in the digital forensic and incident response community are always looking for ways to make things more efficient and get to the results faster. And this is where a tool such as KAPE can really come in handy. One of the main benefits is that it allows you to really quickly target the most critical aspects and artifacts on a Windows system and then collect those artifacts, which means you can do things really fast, right? And that's really the goal of what we're trying to do, is collect as much of the critical information that we need as quickly as we can, so that we can then analyze it as quickly and get to the results. So rather than creating a forensic image of an entire computer or an entire server, how it's typical in a lot of computer forensic investigations, when it comes to incident response, on modern data breach investigations, the trend is typically to do a live collection because it is much faster. Now, when it comes to live collections, there are different tools and scripts out there that you can use for live collections to assist you with that. However, some of them have stopped development, or you start with a tool, it's great, and then 6 months or 12 months later they stop development. So things like that happen quite frequently, or there's very little support and you run into some bugs in the code and you may potentially get stuck. So therefore, your best options typically are going to be to either write your own tool or script to do the targeted collections that you particularly need, or to go with a tool that has a lot of community support, such as KAPE. So while KAPE is not an open source tool, it currently is freely available to download, and the scripts are highly customizable so that you can really configure it to your particular need and style for your case. Okay, so let's take a look at KAPE in action. KAPE's functionality can basically be broken down into two core areas. The first one is the collection of digital artifacts, and that's going to be the collection of things such as Windows event logs, things such as registry hives, user assists, the master file table, link files, prefetch files, etc., etc. And this is what KAPE calls target collections. And KAPE has a lot of pre-configured collection options for these targets, but if they're not sufficient, you certainly can also code your own and just follow the script and the syntax in KAPE. Basically, the target collection, you point it, tell it what to collect. KAPE will go out to a computer, a live system, and of course you can also run it against the collected image and grab that information and pull it in for you. The second core function is the processing of digital artifacts. And that's what KAPE calls modules. So modules in essence are scripts that call other scripts or tools to process and parse specified artifacts. Okay, so let's take KAPE for a spin. First, we need to specify the source, which is the disk image or directory that we want to run KAPE against. And then we also need to specify the destination, which is where you want KAPE to store the collected files and artifacts. And then also you need to specify the type of collection using the target flag. In our case, we're specifying the basic collection as the target, which collects the base minimum of what's probably going to be relevant for most type of collections, including MFT, file system log file, secure boot, Windows registry, Windows event logs, etc. And you can see it's already completed, so it does this process really, really fast. Now, after KAPE ran and collected all this information, we can see that now in our destination, we have these files collected, as well as we have several log files that we can take a look at. The basic log file provides us with what's been collected. And we can see here all of the event logs have been collected. All the prefetch files have been collected. There's quite a bit of information that's been collected. Now, if we want to see some more details, there's also a spreadsheet version of what's been collected, the spreadsheet log that continues to contain more information than the text file. And as we can see here, we have a SHA-1 hash for each individual file, which is going to come in handy for authentication. And then we can see here, we have to the left the actual files. Every prefetch file we can see here that's been collected, where it's been copied to. We can see here all the link files, current destination, automatic destination files, event logs, as I mentioned. So all of that information that we specified that's part of the basic collection when we used the target flag has been collected. Now, if we drill down into the actual directory, into Windows, we can see here the actual prefetch files. In System32, we can see the actual event logs, that they actually all have been collected indeed. Yep, all there. System, security. And we can see here the registry has been collected. The user profiles have all been collected. NT users for the user files. Log file, MFT. Yeah, so all is there. KAPE also has a graphical user interface, and you can call the GUI via the gkape command. And this is essentially what the graphical user interface looks like. Just as with the command line version, you have to specify a source as well as a destination. And last but not least, you have to specify the target collection type. We are going to go ahead and select a few options here. Let's go with the boot configuration files, as well as the file system metadata. And what else can we collect here? Let's grab some McAfee antivirus logs if they exist, some RDP cache, Skype communications if there are any, and let's grab Symantec logs as well so that we have AV covered, TeamViewer logs, and if there's any torrent related content and logs, let's grab those as well. Okay, so now we've built our target selection. Let's go ahead and execute the command. And we can immediately see here that KAPE found 10 targets. And we can see here that it skipped the majority of these targets. And the reason is KAPE does initially run a collection with user credentials, and then it will make essentially a second pass with administrative or elevated privileges to collect system-related artifacts, such as the MFT and log file, for example, as they're typically logged and locked down by the computer. Okay. Now, we can take a look at the log files, for example, and we can confirm exactly what has been collected, and it gives us some greater detail. And if we drill down into the directory structure, we can here see the actual artifacts that have been collected, including the boot config file, the log file, and the MFT. And that's it in a nutshell. That's the very basics. So it's very simple and quick to start a efficient targeted collection running KAPE or GKAPE, the graphical user interface. To give you an example of a KAPE module, let's take a look at another tool written by Eric Zimmerman called EVTX ECMD. Now, this tool does one thing, but it does it very well. It's a Windows event log parser, essentially. So you grab the tool, you point it towards a directory that contains your Windows event logs, and then you give it some filtering criteria. And based on your criteria, it will parse through thousands of logs and then export those logs based on your search and filtering criteria. So based on the event IDs and other criteria that you've provided, and will then export only the most crucial and critical events that match your criteria. And you can conveniently export that into a CSV file, a JSON file, a text file, and there's probably a few other options. And then you can read through or further manipulate and parse that data from there. This is what EVTX ECMD looks like. It's a command line driven tool, and its purpose is to parse event logs. So let's go ahead and run the tool on our directory with event logs. You specify the source location, the output type, and in this case, we want to output our event logs in a CSV format. Then we specify the destination and the name of the file that holds the events that we have parsed. We'll call it event logs collected.csv. And a very powerful feature of EVTX ECMD is that we can filter event logs to match specific criteria, such as certain event log IDs that are relevant to our investigation. All right, so now the command has been executed, and it's parsing the event logs and only including the relevant logs that match our event IDs. Now, this process can take a few minutes, but ultimately it will save you so much time during an incident response or computer forensic investigation. As literally anyone who've ever had to manually sift through thousands and thousands of event logs will be able to attest to that. All right, so we're moving right along here. And each one of these events is essentially parsed from an XML format and parsed into the CSV file. All right, so the process has been completed. So let's take a look at the collected CSV file. So we'll open up the event logs collected. And immediately, if we look at the event IDs, we can see that they've been filtered for us. We see the event ID 4625 from the Windows security log. And as most of you know, that describes a failed account login attempt. Now, if we look further at the event log that's been parsed, we can also see event IDs 4624 from the security log, as well as 4672. We can also see logon type and all the other standard information that you would typically see in a event log. So this is what EVTX ECMD does, and it does it really well. Okay, so the reason I wanted to show you this tool is because we can call the tool directly from within KAPE, so that we can not only collect event logs, but also parse them from within a single tool. In order to call EVTX ECMD directly from within KAPE, we would use the KAPE modules. The mSource flag to specify the location of the files we want to parse. We then specify the module, in our case that would be EVTX-CMD, and then we would use the mdest flag to specify the destination of where we want to store the parsed event log CSV file. So once we have the syntax here, we're going to go ahead and cut it off and run. There we go. Execute it. The process has started. And we can see it's already generated the output file. So while this is doing its thing in processing, let me go ahead and show you another thing. Now, these are the KAPE modules, and effectively you can look at them as the other tools and commands that KAPE calls that are external to the tool itself. They follow a very basic syntax, as you can see, and you certainly can write your own modules as well. And you can see here we have PowerShell. We have Plaso. If, for example, you want to use it to build a timeline, you can also call that directly from within KAPE, and you have a lot of modules there. All right, so now our command has finished its execution. So let's go ahead and open up that CSV file. You can see here it's a 73 megabyte CSV file that's been parsed. And in this case, I did not provide any filtering criteria this time. But just as we've done before, you can just as when you natively call EVTX ECMD, you can do the same thing from within KAPE. So you can call the flags and filtering criteria as well. All right, so that was it for our mini intro into KAPE. I hope you enjoyed this video about KAPE. Be blessed, be safe, and stay tuned for more videos to come.